Okay. So the Google Colab, that is the popular kind of platform and very easy to manipulate, to manage, to manage the codes and so on. Probably I'd like to share my screen on that thing. So let's see about that. Okay. Um, okay. So if I just simply search Google Colab, right? So I just type it again, for example, Colab, right? I just search, just if I just type in, then I can see that, yeah, good. So I can see that this is the screen, right? This is the screen. Sorry. Um, okay, so this is the screen, and initially you need the Gmail to access to that, and you have some codes and so on. So if you can click the plus new notebook, so if you just click it, then you can find that a screen will appear. So this is where you can start the coding, right? So I just clearly showed you that this is where you can initially start the coding. And I'm just talking, considering that you don't have any knowledge on any programming or Python, but just remember the steps that the link is given in the PowerPoint, in the link that you can find. Even I can copy and paste it into the chat, right? That you can try if you want to at your end. If you have a Gmail or Google account, definitely, probably you need that, right? Or maybe you must need that. So if you click that, it will appear, and then you can click the new kind of notebook, new notebook. So I'm typing it into the chat. So new notebook, that is basically the thing, and then it will appear. So this is actually where you can, if you just look at the start coding, right? So if you just click it, then you can start the coding, right? And then if you want to code next line, if you want to put a chunk of code into the next line, you can do that by clicking here, or you can click the plus text to write some comments, right? So if you can do, you can write some comments. So it's basically a combination of coding and comments, right? And so on. So the you can imagine it's a notebook in which your comments about the discussions or anything, you can write it. Even you can put picture, you can explain the things, plus you can put a partial code. When you go through the week 1, week 2 lab that will be starting next week, then you will find that this sort of notebook as a file will be given. So you just simply click it, and you can know more about that, right? So if I just, for example, go back here and say, I mean, this is not the time to code. What I'm doing is that from the PowerPoint slide, for example, I'm just copying and pasting a code. This code actually is given. So sometimes it's not copied directly. You need to copy that into a notebook to so you can copy from anywhere. Sometimes, due to the formatting issue, it's not copied directly. You can use the help from a notebook to copy paste as an intermediary step. So I just copied, for example, or you can type in any codes, right? You don't need to understand the code at this stage. So if you just click here, you can see that on the right side, the connecting is working. So it takes time at the beginning, but soon it will basically give the result here. It just running. So you can see the output is appearing here. So which means that it is a platform, right? It is a tool in which you can do the coding. And now if you, for example, want to do another code, two things, there are two options. You can basically edit here. You can write a new code, or if you want to keep that code, you can hide it basically. You can hide it, and then you can copy, or if you just hover the mouse at the end, then automatically this will appear, so you can put another code. then you can write another code here, right? So you can just say, just print hi, right? So if you just do it, and then you can see that the output is here. That's it. So this is one of the platform that we'll be using. And when you save the file as a IPYNB, then you can see all your existing files should appear. In the lab next week, we'll go through that again, right? But in the meantime, you can utilize the time to play with the Colab thing. Another popular platform is okay. One question came. Let's see. Can I just ask before the weekly lecture, should we have done the workbook, lab session, and coding exercise prior? There is no rules on that, right? So you can do anytime. You can do basically anytime. You can do that. That's fine, right? So because ultimately you have to do all the weekly sessions, so you can do anytime, whatever is suitable. If you're really, interested, you can do that before. That's fine. Okay. Any other question? You can. Okay. So this is one popular platform. Another platform is I'm just trying to share this screen. Um, okay. Is there are other tools as well, like Anaconda is one of the tool. Okay, let me just make it clear. Okay. So sorry for that. Okay, I think you can see that. So this is the Anaconda. This is another popular platform. I'm just going through, all the tools that you can basically do, or you can install, So this is also another tool that you can download freely and you can install. So once you install it, what will happen is that you can, after installing it, it will take time. Then you can find, once you open the form, then you can find the Jupyter Lab or the notebook. Both are, one is the web-based, another is an kind of form-based. So there are two. You can use that. You can also use the spider. So all are pretty much similar thing. Whatever you like, you can use, right? And also command prompt is also there. So all these are actually for the um, Python. Now another popular that is also another really popular tool. So I think if anyone have any question, you can type in there. Um, okay, so that is the second tool that I can talk about. Now the third tool that um, I can put forward is called Visual Studio thing. So I'm just trying to find where is the about thing. So welcome. So this is called VS Code, right? Visual Studio Code. You can download it freely, and you can not only Python, you can also practice other, the language here, right? So for example, I just did that. If I run the code from Python, so if you want to run any kind of language, then the corresponding library will be installed. The compile will be installed, and you're ready to go. Really lightweight, right? Really good one. This is really good kind of tool. Um, and the fourth tool, I can say that there are plenty of online Python compiler. There are plenty of online Python compiler in which you can also, work with. There are other websites like W3 Schools in which actually you can compile your program, right? Uh, so I think these are the popular. Again, I mean, you can use the Colab at the beginning most of the time, right? I think I can go back where I was. Okay. Um, okay. So this is what I was talking about, and I just talked about other tools. What am I doing to learn by the end of this class? So what I Moscow do, so we'll see that. So Moscow is a kind of Prioritization technique that helps teams organize and communicate their work. It's an acronym for must have, should have, could have, won't have this time. Okay, and what is a programming language? What a flowchart is. So probably half of the lecture of today is about the flowchart, and we'll go through flowchart. Some of you definitely have the probably have the experience on that, but we'll go formally about the flowchart half of the lecture, right? So before before anything, I'd like to show you that particular video. It's a classroom and some philosophical discussion. Let's see.
Experiment. This, in my way of thinking, is the most important series of experiments ever done in cognitive psychology, developmental psychology, actually. So here's how we get started. There's a rectangular room if you're a person. If you're a rat, it's a rectangular box. All the walls are painted white. You with me so far? So now, in each corner, there's a basket or a cloth or something under which you can put some food. Now, you put the food there while the rat watches you. And then you give the rat a little spin to disorient it. All right? So then the rat stops and goes for the food. And you can keep track of where the rat goes. And the rat goes with approximately equal probability predominantly to those two corners. So I bet you didn't know that rats were that smart. So they understand the rectangular nature of the room, and they don't go to the diagonal corners where the food cannot be. So are these genius rats? Or maybe we're just rats with big brains, because we do the same thing. So if you repeat this experiment and replace the rat with a small child, and then you put a toy in there instead of food, and the rat, the child is usually held in a parent's arms, usually the child's mother, usually because they think that if they participate in these experiments up there at Harvard, the kid will get into Harvard someday. So the kid goes to the diagonal corner, just like a rat. And then you next thing you do is you try an adult, maybe an MIT student. In that case, you can use food again. And you get the same result. Who could be surprised? So rats, children, and human adults, pretty much all the same with respect to this experiment until you paint one wall blue. Rats are not colorblind, in case you're wondering. Then what happens? Well, if you paint one wall blue, the rat still goes with equal probability to the two diagonal corners. If you paint one wall blue, the child still goes to the two diagonal corners with approximately equal probability. It's only us genius human adults who go only to that corner. So this invites a couple of questions. One of which is, when does a child become an adult? Any ideas? Leica, what do you think? Yeah, you can pick a number greater than 1 and less than 10. Manasa, what do you think? 5? Pretty good guess. Do you have siblings at that age? It's a surprise, but why is it 5? Is it because, what does it relate to? Is there any correlate to the onset of that ability? You might try everything as Spelke does because she's extremely careful. So she's tried gender, she's tried the onset of language, I don't know, the appreciation of music, handedness, and there's only one thing that matters, and that is that the child becomes an adult at that time when they start to use the words left and right when they describe the world. Now, I said that very carefully because they understand left and right at an earlier age, but they only have started to use the words left and right when they describe the world at the time that they begin to break this. They begin to break this symmetry and go to the correct corner. Now, for the next element of this, I need something to read. Has anyone got a textbook handy? There we go. China, illustrated history. Now I need a volunteer. Okay, Andrew, you want to do this? So here's what you're going to do. You can stay there, but you can need to stand up. So what I'm going to do is I'm going to read to you a passage from this book, and I want you to say it back to me at the same time I read it. It's as if you were doing translation, simultaneous translation, except it's English to English. Gosh, this thing's got words I can't pronounce. Okay, you ready to go? All right. When overwhelmed by the magnitude of the problems he tackled, he began to suspect that others were plotting against him or secretly ridiculing him. So it's not, thank you very much. That's great. So you see, he could do it. Some people can't do it. At least it takes a little practice. But he did it. And guess what I've done to him? I reduced his intelligence to that of a rat. Because if you do this experiment with an adult human who's doing this simultaneous English to English translation, they go with equal probability to the two corners. So what's happened? What's happened is you've jammed their language processor. And when their language processor is jammed, they can't put the blue wall together with a rectangular shape. So it seems to be that language is the mediator of exactly the combinators you need in order to build descriptions. Because they can't even put those things together when their language processor is jammed by the simultaneous translation phenomenon. So that brings us to the two gold star ideas of the day. And one is, if you want to make yourself smarter, you want to do those things. Look, listen, draw, and talk. Because those are the particular mechanisms that surround this area down in here, which is the center of what we do, which is the center of our thinking. So why do you take notes in class? Not because you'll ever look at them before, but because it forces the engagement of your linguistic, your motor, and your visual apparatus. And that makes you smarter, because it's exercising that stuff. Second thing you can say in conclusion, especially from this experiment, is beware of fast talkers. Why do you want to be aware of fast talkers? It's not because they will talk you into anything. It's because when they talk fast, they're jamming your language processor and you can't think. That's why you want to be aware of fast talkers. Because if they jam your language processor, you won't think and you'll buy that car, or you'll buy that drink, or you do any manner of things that people who want you to do those things have learned to do by talking fast to jam your processor. So that completes what we're going to do today, and we'll give you a demonstration of some of this stuff on another occasion.
Okay, so, pretty much a different perspective of the language, and that we're learning the computer language, right? So anyway, I don't want to comment on that. Anyone would like to comment on that particular video? What did you find? You can just write in the chat. I just move forward. Like the lecture playlist, of course, you don't need that because, in the Moodle you can find all the links. The lecture will be recorded and uploaded to the LMS, and any question, post it to the Zoom chat or into the forum post or the weekly post or anything. Now, who wrote Python? This is the guy who actually wrote the Python. So he said that Python is a great language for startups because it's easy to read and learn. It's versatile and can be used for web development, data analysis, AI, and more, right? In fact, all are true, right? All are true. And like this is a game, a game, a program, game programming that was done using Python, some of the libraries. This is used for virtual reality temporal bone simulator. And this is the top companies that are using the Python, right? So this graph is really interesting. I just jump quickly. Even in the big ones, they are all using the Python, right? Alphabet, the group of the Google, right? The mother group kind of thing. This graph is an interesting one. For the blue color is the Python, but you can see that this is the recent time is the number one. However, it was not there really, right? The other languages were actually dominating, right? So it became at present is the number one almost almost in every areas. Like in AI, this is the most popular. Um, and if you can search in Seek about the Python related jobs, you'll find plenty of. It was taken long before, but definitely you can find many jobs on Python. In this subject, so only me, I'm the teaching staff. So sorry, the program is not something that can be learned well half-heartedly. However, if you put some effort in, you'll find that it can be very fun and rewarding. So we need to give time on programming. For the beginners, if we need to give time, it's similar to, I sometimes give an example that it's so one question came is that, okay, was a nice YouTube lecture? No doubt, indeed. Yeah. So that professor, he is actually mainly is an expert in AI. So all of his lectures in AI. So I just put a part of the coding kind of lecture. Will we have access to the slideshow as well? No, actually the coordinator told me, not to open it. So only in the video, you can get it. But any particular slide, I can send personally if you really want. Okay, it's already up. Okay, sorry. Um, okay, and another thing is that sometimes I give the example that programming is like a driving car or playing guitar or any instrument, right? If we do more, we can be expert, right? So that is one of the saying, and that is true, really. Um, the majority of your learning will take place in lectures and labs. So lectures 2 hours per week, labs 2 hours from the next week. We'll be doing the lab after the lecture. There is no face-to-face, so this is the online kind of thing, right? Okay, now so no lab this year, correct. Ahmed, yes. The lab will start from next week. So next week lab, actually, I will try to accommodate week one and week two together. But if you can, do that in the meantime, you can do that, right? You can try to do that, but no lab for the first week. That is just the official thing. So the class will be on Wednesday, 5:30 to 7:30, and 7:30 to 9:30 is the lab. Okay. Uh, so what is the typical weekly flow? There is a reason to write that in this way, right? Is that start because we learned the flow chart. So this is an idea. We try to discuss a process. So flowchart is mainly used for kind of discussing a kind process. So it starts from the start button and ends at stop, right? Or end, whatever you type. Attend the lecture, records will be available. Complete the lab, records will be available. Attend and submit the weekly coding exercise from home. That you have to do. And I think week 2 to 8, all the labs, there's a marks on the 10% marks on that, right? So that is an interesting thing that you have to do the coding exercise every week, and it will be automatically marked. So we'll discuss that next lab. But if you can proceed before, you can feel free to do that. This means there is a work to submit next week, but not this week, next week. All subject material will be available on LMS. There are many resources provided for you: discussion forums, subject learning guide, workbooks, reference for further reading, lab session materials. Probably very quickly, I would like to go through few things. Um, um, so, stream one. For example, this is the website, the LMS thing. In the LMS, so there's a discussion forum under the assessment in which you can talk about the assessment. You have other discussion forum about the subject related question. Now, I would like to go through one of the thing is that we start here. So this subject learning guide, right? That is an interesting one. So this is the basically I should talk about that at the beginning. That I'm doing now. So every week, what we'll be doing. So this today's lecture is about the algorithms and flowcharts. Mainly, we'll talk about the flowcharts in a structured way. And in terms of assessment, so week 2 to 8, basically, 8 weekly coding exercise, and week 10 is the assignment, and which is 40%, and next one is a 2 hour final exam, so 50. And I do, okay, that's it. So I'm going back to here. So if you can see that, I'd like to probably upload the videos under the live sessions. So I'm just going through here, and I'll post into the announcement. Once I finish the lecture, I'll definitely upload that. Even the lab, I'll upload here, right? So all the weekly materials will be there, all the links. In the meantime, I put algorithms, flowcharts, and cheat sheet. These 3 important documents. Feel free to look at that. Cheat sheets is really important for your first lab, right? And also the flowchart discussions and so on. You can have a look, right, on that. So this is basically the 2 lecture that I'm going through. Okay. And I also put I think so this is the hidden one, sorry. Some of the, I think, video you can find on the week. So for example, if you go to the week 1, right? So you can see that the lab sessions, I probably put some previous lab sessions so that you can go through prior. Also, I'll upload my lab session as well, right? That would help, basically. Workbook, you can get all the instructions. Feel free to go through that at your suitable time. And also this is the Python file. So we'll go through that during the lab, basically. But in every week, we can get the materials, right? And go through everything about the resource and other things. Okay. And there is another website which is called Coding Hub, right? So if you search Coding Hub in Latrobe, just search in Google, right? And you have the login. So with the same login, you can enter this. So once you enter here, it's similar to another kind of course, right? In which you can find different languages. So if you click the Python, and feel free to use that. Even in the next lab, I'd also use that to discuss, right? So for example, the basic syntax and variables. So yes, and then the cheat sheet is also here. And yeah, so all these are really cheat sheets. So, you can have the understanding, you can practice that. We'll go through that during the lab. Okay, so I'm just going through quickly all the materials that we may need from the LMS, and you can use that anytime. Okay, so labs are not assessed but are an important part of the subject material and must be completed. 8 weekly exercise, coding exercises 10%, and 1 programming assessment 40%, 2 our final exam 50%. Assessment must be submitted via the LMS and so on. Okay. So submission of all 3 assessment is vital for the success in this particular course. Don't leave the assignments until the last minute. I think if you, one of the things is that if you submit delayed, I think 5% marks will be penalized, right, for every day that you know. So, try to upload before the deadlines. And don't forget of the weekly coding exercise. Click on the week one section on the LMS page to access the week's exercise, right? Um, okay. And the cheating, all assessments must be completed individually. This means that you are not allowed to copy or share the code and make superficial changes so that it looks different. Obtain partial or complete answers from friends, relatives, strangers, etc. online. Okay, if you're unsure whether something is considered cheating, ask me, right? So feel free to, send me an email. Okay, some comment came. I can't see the coding hub. Yeah, yeah. So I think, okay, Hasnain. So if you just search in Google, then probably you can get that link, right? You can get that link. I think you can be automatically access to that, right? Otherwise, I'll try to sort it. Email me, right? Otherwise, email me if you struggle to get that link. Um, uh, Coding Hub. No, I think under the Latrobe. So you have to search under the Latrobe. So just let's see. So okay, I'm sharing the screen of that particular thing. Is that so yeah. So I just searched Latrobe Coding Hub. So I've got the first link, right? All right. So if you just click here, then look at the Coding Hub, right? So they have Maths Hub, Science Hub, all these things. So this is how you can enter, right? And then you need to log in probably and all these things. Okay, log in. Okay. Um, so it just linked with that. So here, right, Coding Hub. So if you do that, then you can enter through the link, please. Okay. So the link, right? I'm not sure. I'm just sending the link, but try that to see what happens. Okay, so not direct to everyone. Um, okay. So we'll just repeat that in during the lab as well, right? All these things. Okay. Now, academic integrity or cheating, right? So AI, generative AI models and chatbots like ChatGPT are not to be used in assessments, right? Ideally, it is expected. Although there are good uses of these tools, a replacement for learning material is not one of them. The analogy is copy pasting output from Google Translate won't do much to demonstrate or improve your Italian language skills. Okay. So anyway, so yeah, to learn it, even during the course, during the lab or during the lab mainly, I'll also sometimes use ChatGPT to get the idea of the functions, more examples, but we should try to, doing the assessment by our own. Okay, that's the expected thing. Reasons to avoid cheating include future learning difficulties, reputational harm, severe penalties, including expulsion and blackmail. Cheating is more trouble than it's worth. Don't do it. I think this is in the long run, it helps to develop the coding skill if we try to take help from, say, anywhere about the understanding and then do the code by ourselves, right? And if we're stuck, we can, try to get help, but not the solution directly. Then we'll not learn basically. These are the books. This is one of the recommended textbooks that you can use. It's really good book. It's a free to download. So I can give the link of that. So some of you would like to get the books. And also W3 School is one of the, I'm sending the link now actually. W3 School and then Python. So the Python tutorials that we can really use to look at all the examples. I'm probably can give a quick demonstration of that particular. Some of you definitely know that, but suppose this one is the W3 Schools Python. So what I did, I actually search and then and went there, right? So you can really try yourself. So like print is one of the command. So if you click the try itself, so you can change the command, you can run it, you can get the output, right? So these are the online tools. There are hundreds of online tools for compiling the languages nowadays, right? GitHub is another one. So you can really try these tools even, but the Colab is the, the fundamental tool that probably you can use. Okay. Now that's another book that is really another good one. You can get the PDF file in by searching. You can easily get the PDF file of this book as well. So that we talked about the Coding Hub, right? This is the link. I think I already sent the link. It provides access to the tutors that are highly knowledgeable about programming, weekly live help sessions. You can find weekly live help sessions. Okay, I'm old school, like, yeah, the books. I think Rhiannon, you found that book links, right? Those two books, you can get one of that if you really want to read from there, right? Um, okay. The PY4 site has links to purchase the book from Amazon. Excellent, Matthew. Yeah. So we can get those. So what I'm saying is that this is one of the book. So this is the PY4 site, right? So I'm just typing that into the chat. That Matthew said that you can really buy the book, the hard copy of the book, right? And also this is another really good books. One of the good books, I just type in here, right? So these are the textbooks that you can try. Subject intended learning outcomes. So after completing this subject, you should be able to analyze a data processing problem, design a solution, and implement that solution as a working computer program written in the Python programming language. The full list of silos is provided as part of the subject learning guide. What we are learning, all these components that is actually listed in our PDF file. Screen for too long. Okay, that's okay. Sometimes I also read from the books. I know no, combinations are needed. Yeah, that's okay. By the end of week one, you should be able to understand the purpose of algorithms, programming language, use the Python interpreter to start an interactive session or run Python scripts and create flowcharts to describe simple algorithms. We'll do that right now. So okay, there are only 33 slides. I have to go pretty fast, but I need to skip some of the things. Um, so these are the situations, right? Why programmings are needed. I think I don't need to spend more time on that, but whatever we look around, right? Everywhere programming is needed, right? Programming is used. So it has, wide range of applications, even in the TV, right? It's completely programmed nowadays, right? And so on. Mobile apps is one of the most popular one, right? In mobile apps nowadays, they're trying to make it kind of device independent programming, right? The native apps are also there, all sort of things. All these are based on the coding. Embedded programming is used here, right? Like the sort of Raspberry Pi or all the low-level hardware programming that is also used in small devices, in ad hoc networks, in the sensor networks, and so on. The programming saves you time. You can write your own computer programs to perform time-consuming tasks. It's like being able to create your own little digital robot assistant. This only becomes more useful as the digital world expands. In terms of you can raise your hand if you want to talk about any applications you find fascinating, right? Just as a first class, we're doing kind of sort of any type of talk we can do. Have you ever found yourself in a situation where you are performing repetitive tasks on a computer, right? For example, look at the interesting one. Probably you have done many. Feel free to write it down, right? Suppose renaming a bunch of songs one by one, cropping a whole album of photos, downloading many files individually, sifting through documents to pull out information, or it's come scrapping the documents, or in a website, for example, to get the information, pull out the information. So one example came downsizing. Ahmed said the downsizing many large video files, right? Very practical applications, right? So we can really try, for all these applications, Python is really powerful. And with only few lines of code, we can do like downsizing all the video files, right? That can be done. We can apply a compression technique to downsize the large video files. We can write a code to do that, right? And so on. Any other examples you can feel free to write, or you can, any solution you can also try to write, okay? So these are the things for which we need to do the coding. You can write your own computer programs to perform time-consuming tasks. Okay, so uh, I have a large digital music collection, so I also have a fairly old car. So I installed a stereo which can play music from USB. So when I tried to use it, I ran into a few issues. The track order within albums was wrong. The volume across sounds was inconsistent. Some songs just wouldn't play at all. These are the problems, right? These are the issues that came. So what could be done, right? So what could be done that I could have manually gone through track by track using an audio editing software to convert every song into MP3 format, adjust the volume and mix. So it's kind of manual process that I can do, right? This is one solution. Sure, this would work, but it would take me hours, right? I don't have time to do that, right? So this is the issue. Furthermore, whenever I wanted to add fresh music, I have to do all it again. So we need to write a program, or kind of we need to incorporate automation for a happier existence, right? Instead, I used my programming knowledge to write a small amount of code. This code was able to convert the songs to MP3, normalize the volume, copy them to USB, and sort them correctly. After a few minutes, I was able to jam in my car. So this is kind of application very practical application to do these things. Now, what are the career opportunities? I mean, if someone is really good at programming, I mean, definitely, um, I mean, uh, people would search, look for him, right? So it's really, really vital. If someone would like to do a IT career, then I would strongly suggest that programming is, the vital is for that. At least the understanding of the programming yeah, it needs to be there. Computers are used in almost all industries, medicine, agriculture, engineering. As a result, and in Australia, even many IT people are actually working with the medicine, the medical sides to do all sort of, program developments and so on, data analysis and other things. And for those data analysis, Python is the number one. I mean, there's no doubt about that. Python is the number one for data analysis. So if someone would like to make a career on data as a data analyst, I also teach AI side, but for that, Python is the most popular one. Even there is a kind of for big data, there is a Python extension for that to do that thing. Anyway, so other languages, other tools are also there, and so on. Business is one of major industry as well. Definitely, definitely. I mean, so agriculture, engineering, as a result, programs are in high demand. Job opportunities are varied. Web design, data analysis, research. Now, one of the interesting thing of the Python is that, I mean, I think that Java was the first, but after that Python, who actually worked simultaneously for website design and for data analysis, and in other application desktop applications as well, right? So that was the power at the beginning with Python basically. Set yourself apart in non-programming positions. Okay. Um, Besides everything else, programming can just be a fun hobby, right? Finding a good way of solving a tricky programming task can be very satisfying. You can turn an idea into a working piece of software and share it with the world. Got an idea for a cool video game, learn to program and make it. And for Pygames, I mean, there are extensions for the Python that is used to develop a game. We found a screenshot on that, right? That is also an interesting one. So human thinking and computer thinking. Okay, the way computer thinks or even human thinks is basically it's a step-by-step approach, right? And that is called algorithm. So an algorithm is a well-defined sequence of step-by-step instructions. There is no single algorithm. Different tasks require different algorithms. Even to do a job, there can be multiple algorithms. Like to sort a number, for example, uh, how can I sort a number, right? From ascending order, descending order. There are plenty of algorithms. Even the algorithms are, evolving. I mean, there are research papers writing on it. So n log n is the complexity of the most efficient sorting algorithm. Anyway, so these are the data structure side or algorithm side. But for any particular thing, there are multiple ways to do the thing, and each way is called algorithm. So an algorithm is lot like a cooking recipe, right? Individual detailed steps with a defined order. Programmers design algorithms and turn them into computer programs. For example, now bit slowly. I mean, I'm just we're delving into the algorithm and then the flowchart. That is the kind of important part we are entering now. So what is the algorithm for making a sandwich, for example? So before, one of the thing is that sometimes people used to learn the programming without really thinking about algorithm or the flowchart. So if someone would really like to, if someone think about the algorithm and flowchart at the same time, then the complicated problem he or she can manage pretty nicely using Python, right? So that's why we talked in the week one about algorithm flowchart that is also really needed at the beginning level, even for advanced level at the same as well. So how to make a sandwich, for example, we can write these steps in this way: that place two slices of bread on the bench, spread butter on one slice of bread using a knife, place one slice of ham on a buttered slice, place two pieces of lettuce on top of the ham, place the unbuttered slice of bread on top of the lettuce, right? So you can imagine that. I mean, probably we can change some of these steps, right? Some of these steps can be different. However, we have these steps. We have these steps to do. So if we change some of these steps, for example, that is my own choice, which means my algorithm is different, right? Uh, so that is actually a steps of a kind of algorithm. In pure English, we can write it down. What is bug? A bug is a flaw in software which results in incorrect behavior. Bugs can arise due to logical errors in an algorithm. It is important to think algorithms through carefully to avoid introducing bugs. The process of finding and fixing bugs is called debugging. This is one of the powerful thing we learn that in Python is the debugging thing. And in case of Anaconda and other languages, they have the debugging kind of features. We'll go through that. Even in normal scripting language, using print command, we can try to debug the status, right? That we'll learn. Okay, so this is about the programming. What is programming language? So computers are logical machines that follow instructions very literally, right? So computers do not understand plain English. In order to describe an algorithm to a computer, it is necessary to write a computer program using programming language. This is known as coding. So one of the things is that some of the uh, historic point of view, which is, say, the assembler, or you can say that the binary codes, for example, right? Like the binary codes is what the machine actually understands, right? Zero and one, right? Zero, one, one, zero, all these binary codes, right? And in very low level, that actually transforms to 5 volt, 0 volt, or 5 volt minus 5 volt in an electrical signal level. That actually on and off a particular transistor to do some calculations. Okay, that is the absolutely hardware level. So these binary codes, the one level up logically is called assembler, assembly language, for example. So the assembly instructions are actually embedded within the processor, right? For example, add, say, X, BX, for example. This is an instruction in the um, within the kind of register inside the microprocessor or the CPU, right? They do the calculations. However, even that particular coding is not user friendly, right? That's why we came up with the third generation of language, right? For example, C, right? Java, Python, right? All these are uh, third generation of language. So what happens, the compiler, they just transform the code to the corresponding assembler, and the assembler is translated to the corresponding binary code. So this is how actually it actually works. So that is the in the compiler level that the transformation happens, and that made the life of the programmers easy, right? Using the third generation language. Also, there is some notations on the fourth generation language in which graphically you can do the things. For example, you can search like App Inventor from MIT to do the mobile apps. If you want to develop the mobile apps, there is a you can search. I mean, these are the interesting things like App Inventor, right, from MIT. You can just you can plug and play the code, plug and play the component to make a code, right? And that is actually working. There are other languages as well. Some of you probably are familiar with that. So anyway, so these are the situations for the programming language so far. So yeah, So basically, okay, Darshik said that basically a translator to trans text code to binary code, correct, right? So a compiler is like that. So a compiler is translating that to a kind of assembly instructions based on what type of platform it is, and ultimately it goes to the binary codes level to make it happen. Correct. That fourth generation like block coding apps, correct. Visual, visually you can just drag and drop and make it happen. But ultimately, fourth generation language, I mean, you need to do some coding as well at the back end, and so on. Now, uh, it's just an interesting point is that, for example, there is a program. It's called Power BI, for example. I mean, just it's from the Microsoft actually, in which, in fact, you can do sort of database programming, sort of many kind of analysis, and that can do most of the things. Nowadays, many programs are like fourth generation at the beginning level, right? However, what they do is that actually made the things easy because of the competition, right? Because you can imagine that if any any company say that in order to do all the data analysis, you can use this program, and we have the fourth generation capacities, then definitely it becomes a competitor to the third generation languages, right? Like the Python, for example, you can say in this way. Does it make sense? I think this is one of the most important thing. Even the data analyst or people in programming world, they're actually using, try to use the fourth generation, and sometimes for some purpose, some work purpose, the third generation thing. Can Scratch be defined as a fourth generation coding app? Scratch, I didn't try it. It's, if it is a kind of plug and play, like all the components are there, if you can just drag and drop and do the things, then it is a fourth generation. Yeah, absolutely, you're right. Similar to the MIT App Inventor that I just mentioned. And Power BI example I gave, that it has database capacities and data modeling capacities, plus using some of the extension, it can do the AI thing, AI analysis, like the machine learning capacities or data analysis capacities, that using Python, you need to do some writing, you need to write the codes, right? So again, this is a competition from the Microsoft, or the other vendors are also doing similar thing, right? So things are changing pretty fast. Things are changing pretty fast, and it's an amazing kind of exponential growth of languages, you can say, and all are for a purpose, right? All are for a purpose for revenue and other things, right? Anyway, so this is how the evolution is happening nowadays. And how about coding like with imagination, right? We know that the neural chip and other things are actually
Oh,
it's
Neuralink.
coming. Yeah, neural link, link, right?
Yeah.
Net on link, yeah. So these even if it becomes popular, then definitely programming will go there. How to do the coding in using that thing by imagination, and so on. So these are the interesting observation. One of the things just came to my mind, which is the long ago actually. I don't know the recent status. It's called Rational Rows. Was one of the IBM product. They actually gave the idea because it is relevant. That's why is that using the flowchart or the UML design, not flowchart, UML design. UML is similar to flowchart, not exactly flowchart, similar. So they actually, you model some ideas using the, you can imagine flowchart, but that's actually the UML. And then that program will translate it into a Java program. So it's an interesting thing, right? So you are writing the model, just the flowchart, and the flowchart will be automatically translated to a Java program, Java coding. So which means it's a translation from fourth generation to third generation, and that's it. So you don't need to write anything, right? Your program is ready based on your imagination. So that is still there, similar thing, but you need to edit the code and so on. But even this is one way the progress happened. But there are other ways that even in the third generation language, they made the function so systematic, so easier. They put the object-oriented concept. They gave, thousands of libraries, libraries to do the job in just in one line code. So, which means that then people would like to, do the complicated programming very quickly, using their help during the coding. So, and with the advent of the AI tool, they are actually giving the ideas clearly to the programmer. So programmers are getting nowadays a lot of help to do the complicated coding. So this is how the evolution is happening. So even in, for example, we started the course today, 20th of November. Probably after 1 month, even a new change can happen. So things are changing, quickly. We need to be aware of what's happening around, and so on. Okay, so we talked about the machine code. I talked more like it's similar to, you see, the hex code, and so on. So jump comp. So this is the assembly code for a particular processor, and this is the corresponding hex code. Hex code is actually the binary code, right? Which is can be translated to, because basically it's a binary code, but when it shows as a hex code. So machine code is fast and natively understood by computers, but is very, very difficult for humans to write directly. Definitely, that's why we need the third generation language. Anyway, I talked about that. Any question, you can just write it there, but I think we just dive into the Python. So the first version of the Python programming language was released in 1991. Now it's the 3.6 in 2016, but I don't know. The present one is really pretty new. Python is readable, right? For example, if I want to code, say, for each item in the store's inventory, if there are two or fewer in stock, display low stock message with the item name, right? So for each item in the store's inventory, right, which means there is a list of items. I want to scan everyone. That is actually done here. Okay, you don't really need to understand now. That we'll learn on week 3 or 4. So this is a for loop. So stock inventory has all the list, and it's going through one by one. And the first element goes to the item, then the next element will go to the item slowly, right? And so on. So when the first element go to the item, then I'm entering into it, and then I'm checking with if. So by the intending, it means that I am actually, these codes are actually working under that for loop, under each item, right? So when I hold the first item from the store inventory into the item, that particular item is actually analyzed here, not the other items. So when this analyze is finished, this step is finished, then actually it goes here. Then from the store inventory, it picks the second item. Then again on the second item, that two lines will be executed. When this execution finished, then it goes back here, the compiler, and then it picks the third item and so on, right? So, okay, I mean, how it works, I just told you, but that later we'll revisit that. But what I'm saying is that it is actually similar to English language, right? Not that far away, right? It's similar. So for item in a systematic way, right? If item stock is less than 2, then print low stock for item name, which means it's a readable. Simply, it's readable. It's not like I'm writing a code in this way, right? I'm writing a code in this way. Before the third generation language, people used to do the code in this way, right? They need to understand and think all these things. Okay, you can even search assembly language. You can get some idea in ChatGPT, get the idea of the, if you wanted to add two numbers, you can see the code, right? That will give you the idea that how difficult it was. Okay, so this is the readable language. Now, this slide is really, really useful, right? If you want to really, go far, delve into more into more practical applications, this slide has everything. So for AI, PyTorch, TensorFlow, these are actually extra libraries, developed by third party vendors. Sometimes an individual person probably made it, you know and that you can integrate into the Python easily, right? So it has a large ecosystem, means that people around the globe, they contribute developing the libraries. They contribute developing the libraries. How popular a language is, that answer we can find that how many libraries they provide, right? Do they have a good number of libraries? For example, I mean, this is a really good exercise. You can search that for AI, for artificial intelligence, how many libraries Python is providing, how many libraries Java is providing, how many libraries, C, C++ have, this is a way to really compare. Probably your area can be different, then probably you can find another language, maybe. Okay, I thought they were extensions. Yes, you're correct. It's called extensions. Yes, these are the Python extensions. Okay. Now for data analytics. Now this is the most popular part. Even the AI component is used on top of the data analytics library, right? Like even I basically use for AI. There's a tool called scikit-learn, right? Scikit-learn. It's a minus. That is also a popular kind of tool. Now, for data analytics, NumPy, Pandas, Jupyter, all these libraries are used. That is very, very popular. Web development, Django, Flask, all these. Game development, I never tried, but you can have a look. Pygame, Panda 3D, plugins and macros, LibreOffice. Okay, so there are other tools as well. So these are the popular term for all this. And I just task. I'm just searching one thing. Okay, there is another popular one. It's for the parallel programming, or for big data, because that is one of the popular term, big data, right? Big data analytics. You can search Dask, DASK. Dask is an external library for Python, in which actually, a task can be partitioned and run into different clusters, different CPUs, multi kind of processing kind of environment. So fascinating thing can be done in Python basically, right? Using those extensions, right? Okay, so I think any question or comment, feel free to write. Or if you have any other feedback, please write it down. Then I can also learn things. Okay, so one comment came. I'm home. I leave home. Okay. Will Yes, the lectures and labs will be recorded. Definitely, you can catch up later, right? You can catch up later. I will upload that after the class. I'll upload that after the class, so don't worry about that. Even we have a, I think, weekly catch-up session. We have a weekly catch-up session that I'll try to write it down, which time, for 2 hours. You can actually book an appointment. If you have any question on Python or anything, we can do the Zoom meeting one-to-one, just to give the ideas. Okay. Can I withdraw from the subject? Yeah, that's fine. That's the admin thing, right? If you want to withdraw, that's your choice. Could you please explain further about parallel? Okay, okay. But that I just thought, I mean, the parallel programming. Okay, let's see. I'll probably share one screen to explain that particular thing about the parallel programming. Welcome to the task tutorial. Okay, so on this one. So what parallel programming is doing is that, in general, we have a sequential process that works, right? When we write an algorithm, it's a sequence process. For example, I just give a example in this way. Say this one. Can you see the code? Right? I'm just explaining the parallel programming a bit of. So in this code, suppose just try to imagine that for item in store inventory, suppose the store inventory is 1 billion entries. It's a huge data, right? 1 billion. So 1 billion is a big number, no doubt about that. So how long does it take to run? Definitely, I mean, weeks. I don't know, or weeks, sometimes days, depending on how fast your computer is and so on. Not no billion is not weeks. So what I'm saying, I mean, suppose it's billions of billions, say, right? It's a big number. So what happens in parallel programming? They try to make it into different partitions and then send each partition into different CPUs to calculate in parallel. Does it make sense? So to calculate in parallels. So and then get the result, accumulate the result, and give you the output. So definitely, if there are 4 processes running, depending on you have the 4 times resources available, which means it will be 4 times faster, right? So this is how actually you can manage the things, right? So if you search in Dask Python, you can get a lot of pictures, descriptions, all these things are there. So parallel programming is one of the, it's also called cluster programming in some of the languages. Okay, so I think that's it. I mean, you can just search it and get more ideas on that. Any question, just write it down. Okay. So for the Python, you can download it from here. There is a web link given, python.org downloads. You can download it. Or if you download the Anaconda that I just said, that you can also do that. You can search it. So once you download it, what happens is the Anaconda has an external kind of IDE, in which actually you can nicely debug the program. That is really powerful. You can debug the program. Of course, you'll be using the notebook under Colab, but be familiar with all these tools. It just then actually you may end up finding one of your favorite tools, right? That's why I just keep I'm discussing all those tools. I'm not sticking to a one particular tool. You may end up liking a different tool. So every tools have are fun basically, and they have nice features. There are instructional videos on LMS which walk you through setting up a Python development environment. Even in YouTube, you can find that how to install a software, right? So please email me if you struggle to install any of these software. These are pretty stable software, pretty popular because Python is popular and these tools are really popular. So it should install without any issue, right? But if you find any difficulty, email me. In the meantime, try to use the Google Colab. So in Colab, definitely in the Gmail, you'll not find any problem there. Okay, so I open the next slide, which is the flow chart. Just quickly, probably I'll give a break after a while, but I need to start it first. Okay, so just opening that flowchart thing. Okay. So what is flowchart? So let's say you want to start a house cleaning business, right? So any scenario, any situation, any thoughts, any dream, right, or any imagination, we first need to write it down in plain English or using some diagrams, right? That is the basic idea of flowchart or algorithms and so on. So first we need to understand the the things first to make the plan clear. So we want to start a house cleaning business. So you hire 3 employees and you start taking customers. So after running your business for a while, you start receiving complaints about inconsistent results. You decide to investigate. So you take each employee to a bedroom and instruct them to clean the room. You observe 3 different processes. So you see process. So we talked about the process. So each process we need to discuss as an algorithm or as using a flowchart, right? So any flowchart is basically part of process. It is a process. So what went wrong? So clean the room. If I give the instruction clean the room, it is not a precise description of the task to be performed, right? So because when I say someone clean the room, so you have kind of a different perception than me, right? So everyone's understanding is different. So the instruction should be really clear, right? It depends on different things, experience and past experience, and mood, etc. So we need to document the steps in detail without room for interpretation. Design the algorithm. So when we write something clearly, then the other people cannot think otherwise. Basically, that's the idea of algorithm. So we discuss something, which means that the other people would agree, would understand exactly the way I'm thinking, right? I know it's challenging. Sometimes it's challenging, right? Like in the offshore programming, sometimes the challenge is there. However, those flowcharts, they are giving more concrete ideas so that the understanding of the author and the reader becomes same. For example, if an author, it's interesting that if an author write a novel, then the reader can probably understand a different thing or a different theme. And probably the author never thought about that. We know that that actually happens, right? But in programming, if it happens, it's a nightmare, right? It's a danger because the client didn't want the other things. He actually dreamt something, and in his program, he wants to implement that, right? Anyway, so that's why this flowchart should be kind of a tool which can give the the exactly same idea. The idea cannot be manipulated or cannot be altered, right? Or cannot be different. Okay, so we need to describe everything in the process. So, for example, one way to describe the process of the house cleaning in this way that begin by dusting the furniture and blinds. So look at that. The instructions are clear that this is the first step. That dust the furniture and blinds. Next, vacuum the floor. So if the floor is carpeted, then you should shampoo the carpet. Otherwise, if the floor is not carpeted, like the timber or tiles, mop the floor, right? So the instructions are clear. All the steps are clear. Then we can say that it's an algorithm. And then only we can draw a flowchart out of it, right? So to be an algorithm, nothing can be, um, nothing should be without any steps, right? If we write that do the cleaning, do the dusting, vacuum, and no clear steps are mentioned in the writing, it's not a clear algorithm, right? Uh, Now, this particular algorithm we can draw using the flowchart. So, for example, this flowchart is really, really vital because we have to exactly follow that structure, the notation that we taught in the class. Of course, in the website, in different books, you can find different notations, but this is actually not allowed. So probably in the exam, whatever notation, remember that whatever notation we are using, the flowchart, please strictly follow that. Okay, so if you use other, probably, um, because the unit coordinator will instruct me. I'm talking about the final exam, right? Or even the assignment, like the week 9 assignment, probably, probably I'm not sure because he will actually set up the question. If there is a flow chart, then definitely you have to follow the convention or the notation used here. Okay, I think it makes sense, everyone. Okay, so start is so look at the process. So start and the end or stop must be there, right? So start and the stop, and then we have some steps, that dust, furniture, and blinds, first step. Then arrow, which means this is the next step, is vacuum the floor. Then it goes to a different kind of symbol, right? It's a rectangle kind of thing. Carpeted. So it's a question. It is asking for a choice. So it's basically a choice, that is the room carpeted? And any choice must have multiple outputs, right? No or yes. Sometimes it can have three, but highly unlikely. Most likely it is two output, yes or no, right? So if it is no, then mop the floor, which means this is either timber or tiles, right? And then it goes here. And otherwise, if it is carpeted, then shampoo the carpet, right? And then it goes here in an empty circle. So this empty circle is basically kind of joining. It's a kind of joining, right? Definitely, we cannot have both inputs at the same time. Definitely not. So if it comes in, it must be absent. If it comes in, it must be absent. It cannot be simultaneous, right? It cannot be simultaneous, and then it stop. Now, one of the advanced thing I would like to say here is that we'll talk about that. There's a language, it's called BPMN, Business Process Notation. BPMN, Business Process Notation. So let me just search it. It just came to my mind. BPMN. Yeah, BPMN model. BPMN model. So in which you can just try to think that how people can modify the concept of of these flowchart. For example, like here I told you that it only one of the input will come, right? So if it is active, it is inactive. If you mop the floor, definitely it must be absent, right? But what happens if both are coming in a situation, right? uh, I cannot give an example now. So this type of scenario, if both needs to come at the same time, then another notation we need to use. So what I'm trying to say is that in the advanced level of semantic analysis, like the BPMN, they actually try to capture all possible thoughts or scenarios to integrate into the model, right? To make it more to handle the more complicated scenario. Anyway, so I just gave an idea that it can be, difficult sometimes, or a complicated scenario can actually come here. Then we have to search corresponding, the diagrams or construct to draw it. Anyway, so this is a simple one. So I'm just repeating again: start, first process, first task, second task. This is one process. So even you can say it's a sub process, but just make it simple. It's a task one, task two. This is an option or choice. If it is a floor not carpeted, then timber or tiles, mop the floor, otherwise shampoo the carpet, and then stop the process, which means this is done. The house cleaning is done. This is a flow chart, right? So a flow chart diagram details the flow of the process used to document or communicate a process. Okay, one question came. What would be a decent
เฮ้
example
ยดู
if,
อะไรอยู่
oh, sorry.
เกมเหรอยุบก่อนเอาอะไรนะ
Okay, sorry, just,
นี่เอาอะไรลัสบ็อกอ่ะ
uh,
ขอโทษอ่ะ
sorry.
อยู่ที่มันสบายอ่ะดีกว่ามีเหรอพักก่อน
Okay. So one question, what would decent example if there were to be three options? Jack asked. Three options means here, right? You're talking about. So three options it can be handled, right? Like for example, if the output is 1, 2, or 3. So that is also possible to do. Okay. Is it okay, Jack? I mean, I think you are asking that, I think, right? Anyway, so it says yes or no. Oh, no, yes or no for this particular scenario. right? Three options means what? What did you say? I didn't understand. Three options means like suppose it's a not Boolean, right? It says that it's timber, it is tiles, it is carpet, for example. We want a different process, for example. Then you can draw a three different arrows. That is also possible. Make sense? Yeah, okay. Now, okay. Flowcharts can be useful tool for designing computer programs before writing the code. So this is really important, right? Before writing the code. So the students here who really didn't do any coding before, so this is really, uh, I mean, from my experience, it's really challenging at the beginning level for the programming, but these idea of the flowchart and the algorithm at the beginning level is really, really important for the people who actually started the coding for the first time. So some of you really who study the programming, even if you read a book, probably the book didn't talk about the flowchart at all. Probably that book didn't talk about the algorithm at the beginning. They straight away dive into the coding. But I strongly suggest to look at the flowchart and to understand the process and then go to the coding, right? That is how this PowerPoint is actually organized. That will help basically. So it helps you to think through the individual decisions and steps involved in a process can be translated into actual programming code afterwards. So after that, you can do the coding. Okay, so this is a really good example. So this was the first flowchart. Look at that, introduced in 1921. No computer was there, right? Even they actually draw the flowchart. It was about loading the rifle grenades, right? What is steps one by one? I don't want to go there. You can just search in Google, you can find that. But it is showing that step one, step two, step three, and after this step, another multiple steps are there, and so on. So you just look at that. This is used for the military. So these are the first flowchart kind of on 1921. Again, going to an example, we already covered that example. We need to look at the elements. So the first element is the start and stop elements. Definitely it must be there. So in a flowchart, if you don't put start and stop, flowchart is incorrect. You must have a start and stop element, right? Second point, it must have one outgoing arrow, only one outgoing, not more than one. And stop must have only one incoming arrow. So 1 point. So you can imagine, okay, what will happen if multiple process can end here? Then probably you need to put a circle. All will come to the circle and then only one output will come here, right? We'll see that soon. So, but this component has only one incoming arrow. Each flowchart should include one start element and one stop element and represent using a rounded rectangle. So again, just from my experience, when you draw the flowchart, even for the assignment, exactly follow the same notation. Suppose you are using a software, because we are free to use, you can use any software to draw, but in some of the software, you probably may not get that rounded rectangle. So if you don't get the rounded rectangle, if you use the normal rectangle, it is completely wrong. So somehow you have to make the rounded rectangle, right? That is actually called matching the notation that is followed in the class, because definitely the unit coordinator will instruct me that follow exactly the notation that is taught, not from any other textbook and so on. Okay, so in case of process the elements, so this is the first component, right? Start and stop. And any process element means task. I talked about the task. For example, these are the tasks, right? Dust, vacuum, shampoo, right? All these are actually verb, do something, right? All these tasks are actually called process. So process elements describe a processing step, one incoming arrow and one outgoing arrow. Remember all these. So you cannot use multiple entry or multiple outputs, just one. Description usually starts with a verb, right? It makes sense. Pay the bill, right? Pay is a verb. Flowcharts can include many process elements and represented using rectangles. So this is not rounded. This is just exact rectangle, 100% rectangle, right? Now the color is optional. There is no such thing on the color, just the shape matters. Input and output elements. So input and output elements describe points where data enters and leaves a program. For example, when you try to accept user input or display the output, right? So taking any input, like input the name, take the input from the user, what is your name, for example. So this is taking inputs, and display the cost, display output or anything, right? That is the display kind of thing. And all these are represented using parallelograms, right? Using that kind of shape. You have to exactly use the exactly same shape. And flowcharts typically include at least one input and one output element. Typically include at least one input and one output element in the flowchart, right? Okay, so here no such thing is there, but anyway, but usually, typically include. Okay. Now, decision elements. So we had a decision here, like carpeted, a question mark. So similarly, a decision element is, for example, decision elements select between multiple flows based on some kind of test condition, based on some sort of test condition, right? Okay. So, for example, this is an input, and it is checking that in this particular step that is age is greater than 65 or equal 65. If the answer is yes, go here. If no, go here, right? So one incoming error and multiple output errors. We already discussed about 2 and 3. It can be multiple, right? More as well. Often phrased as a yes or no question. Often, right? Not all the time. Represent using diamonds. Diamond shape, right? Is the decision elements. So far we came across stop and start elements, start and stop, process elements, input output elements, decision elements. One thing is really interesting. It's a kind of, again, another advanced thing, which is not advanced, it's kind of additional thing, which is like any process element can itself be a separate flowchart, right? To make the things easy to explain. Sometimes in practical documentation, in real life documentation, that actually happens. For example, this is a flowchart of cleaning the room. So if you want to discuss that how to do the vacuum, so for the vacuum flow, you can have to explain this process, you can have a separate flowchart only for to explain this particular vacuum. I think makes sense, right, everyone? So it can be, flowchart inside a flowchart inside a flowchart, right? That is also possible to do. Any comment, you can write it down in the chat. Anyone have any question? Sorry, I didn't ask you the questions, but this is the right time to ask questions. Anyone have any question on flowchart so far? So what I just said at the end is that any process can itself be a separate, can have its own flowchart if you want to discuss it more, right? Because sometimes if you want to discuss the vacuum flow here, then the overall flowchart can be very complicated, right? Because flowchart is not simple, it can be very complicated. So sometimes you can hide a individual step, inside the process. And in a separate page, you can explain the flowchart of that particular process. I think makes sense, right? Is it okay, everyone? Okay. So connectors, right? That is an interesting one. So when you need that, when you like all these elements have a limitation that only one output, one output and one input. So for example, if you want multiple multiple type of input into this particular thing, then definitely use a connector in which you can take multiple input and give a single input to its to that one, right? To that one. Okay, so this is an interesting thing. We'll look at an example, then it would be clear. check your understanding. So look at the question. So what are the expected outputs of the program described by the flowchart when the user inputs an age of 19? Please give the answer into the chat, or you can talk. So what will happen if the user input is here? Excellent. Uh, so what's happening here is that we take, excellent. So we take the input here, age. So the user is giving the input as 19. So I'm checking in the next step, is age is less than 18? Answer is definitely no, right? It's a 19. So what's happening? No, I think um, so so age is greater than 18, right? Age greater than 18. So age is less than 18. So no, right? So output is adult. It's going here. So it's giving the output adult, and then it is giving the output ticket, right? So I'll get both output, adult and ticket, right? Adult, ticket. So the output would be simply, you can just try to imagine in this. So this is an interesting one, is that, um, sorry, I'll just write it down. So, so the output would be in that case, simply adult, ticket. That's it, right? So first adult will be printed, and then the ticket would be printed, and then they stop. But if the age is less than 18, then concession would be printed and ticket would be printed, like concession ticket, right? Which makes sense, right? And then the card will be printed, for example. Okay. So yeah, that is actually explained here. Another one, slightly different one, slightly different one, different. I'm not saying difficult, but all are actually easy, right? So the computer picks a number between 1 and 100, and the user tries to guess that number. Whenever the user makes an incorrect guess, receive correct. Connector is used to receive multiple input, right? That's it is really important, because some of the input cannot take multiple inputs. So the only thing, you have to use a connector to handle that situation. Okay. So you pick a number. Whenever the user makes an incorrect guess, they are told if the number is higher or lower than the guess. When the user correctly gets the number, a victory message is displayed that it matched, right? And the program stops. So what is the example behavior? That generate a random number. Suppose the number is 44. Input user guess, suppose 25. Is y equal to x? No. If x is greater than y, display higher. Then guess another number. Again, check if it is yes, equal or not. No. If it is higher, if it is lower, then display lower, and so on. So this is how actually it flows, right? We try to optimize that, kind of, try to make it more systematic. So we can analyze the example behavior to identify the flowchart elements, input, output, decision in the process. So for example, we just identify from these steps which one is the input. Like input is whatever user is, inputting the guess number. And display is whatever is printed out is the display output. And this is actually, that's it, right? And this is the input and output. And what is the, so for example, input guesses y, display higher, this is how we can actually write it down. Definitely. Okay. And there's another message, correct, right? That is actually clearly, these are the options we really need. Identifying the decision elements. So the red color one are the decision elements, right? And any decision elements we need to write in this way. We need to write in this diamond sign, right? So is y equal to x is this way. Is x is greater than y this way, right? We need that. Identifying the process elements. So generate a random number is a process. Generate a random number is a process, and the process is generated using a rectangle. That's it, right? Okay, now with all the elements that we found, like this is the input output, this is the decision elements, This is the process elements. We can make our model like that. Start and end or stop must be there, not end. By mistake, I'm always saying end, but it's stop. Where do we need to follow exactly that thing? Then a process generate a random number between 100 and x. Then you see the connector, right? Because many options can be there. At the beginning, you cannot put the connector actually because our human mind cannot work, super fast in this way. But with more experience, you can do that. But that's fine. You can put a single line. Then when you find multiple lines are coming in, then you can put a connector. Okay, we'll see that modification in another example. What I'm trying to say is that when you initially draw the diagram, you probably draw the single line and then you draw the other things and then you can see that it's coming back here. When you see multiple input lines are coming in, then just simply just delete that or rub it off and then put a connector to handle the multiple inputs and give single output, right? So this is how actually we integrate the connector. So input guesses y. So if y is equal to x, then yes, it is correct one. If no, then say that it is higher or lower, depending on if it is greater than or equal to y. So this is an interesting because the game ends when they're equal. When what I guess is actually the lottery number, for example, right? Is the same number. That is actually checked at the beginning in general. And if it is true, then jump in, right? That's it. Otherwise, there are two options. Either it is small or large. So you can either use x is greater than y or x is smaller than y. Both are fine. So one will go to yes, another will go to no. If it is yes, then display higher, lower. And if display higher and lower, we know that that process will start again because the process will continue as long as both numbers are equal. As long as both numbers are equal. So whatever I'm guessing, the computer is guessing is equal to what I'm typing in. What I'm typing in is actually equal to the guessing. So you can imagine it is a simple lottery game that I'm actually making here, like, right? Or a kind of gambling game and whatever. So this is the thing, right? So again, the first line must be the equal, which is the end result. If it is equal, then you can do. Otherwise, you can go here. Any question or comment? Okay, so Jack Jack said that should a programmer's brain generally work pretty fast? Well, I mean, if I ask a question, say that uh, that are you expert driver, right? It depends on how many kilos you have driven, right, and so on. So it depends on that. A programmer, when he did lot of programming, then definitely on a particular domain, his brain should work pretty fast, right? Um, so that's actually it happens, right? Even you will see the difference, right? Even if you do the Python programming for 1 year and 2 years, you will find the steps are pretty fast. That actually true. Okay, now so I think any question on these, I think that makes sense. So if I ask a question, I'll not give the answer. That can you count that how many times I tried before I come to the equal situation? So where should I put that particular number? What I'm saying is that I need to do a count operation in which I'll do a count that how many times I actually tried to find a equal situation. So in that case, what I can do at the beginning, like here, generate a random number 1 to x and make a counter 0, right? Make a counter 0. So when I do the equal, then simply say correct and then print that counter. Here in this particular step, you can do that print. So this is a display. So print the counter. But in x is greater than y, then increase the counter size. So here actually, so when it goes here, it just display. So actually you cannot do that in that particular process. Okay, you cannot do that because to do that, it is an additional instruction. Are you following, everyone? Additional instruction to increase the count. So to do that, actually, you need to put a similar type of diagram here and here as well before printing out, because within the printing out, you cannot really do a further operation. Okay, I just gave an idea. It's a kind of food for thought, right? That how can you, I'm just writing it into the chat or maybe here because it's a video recording. So it might be useful, I mean, to think later on. So say, how can you integrate a counter which counts how many times I tried before I reach to a situation x equal to y, right? Okay. So how can you integrate a counter WH count in the flowchart, right? Okay, so that is the question. So how can you integrate a counter, right? So I gave the clue that you have to in this particular process here, you have to put a counter equal to 0, and when it is not equal to, in this situation happens like it can be yes or it can be no. In both cases, it again go back here, right? It again go back here, right? So definitely, you have to put a process here. You have to put a process here and here in which you are incrementing the counter. So what I'm saying is that so in which actually you can say count equal to count plus 1. I think makes sense, everyone, right? And also you have to exactly copy and paste it here. Which means that you have to put an arrow here, right? To modify that. Okay, I think, yes, that makes sense, right? So this is the change you can think of and so on. Any question? Oh, okay, I think it makes sense. So yeah. Okay, affective flowchart. Order is important. I'm not following with, oh, so count plus 1. So what I'm saying is that I'm trying to find out that how many times I tried. It's a recorded. Later you can look at the video. So if they are not equal, it can be either bigger or smaller. So in both cases, I need to increase the count value, because if the previously counter, so here actually, count equal to initially 0. Count initially equal to 0, right? Count equal to 0. So display correct, and and also the count, print the count, right? Or display count, right? Say display count, right? So what will happen is that this display count will show you the value, right? So the loop, everything is happening. So just forget about the loop. Just focus on the flowchart. So in the flowchart, how can you present this type of concept? Make sense, everyone? Yeah. Okay. Excellent. Okay. So design and effective. So it must be clear, concise, and complete. So like start, download today's forecast temperature is the temperature over stay thing. So this is wrong because there is no option, right? But if there is a no option, this is all. So you see that we need to consider all possibility, right? You cannot do only one. So where's the no option? Where are the multiple options? It can be 3, it can be 4, right? If it is only one, this is not an option, right? This is just a step. So in the option, you cannot have only one. Also another thing is that um, this is also another important thing, that you are inputting guess here and also inputting guess here. So you need to put only one box, right? That is done by using this way. I think it makes sense, right? I'm just finishing quickly. Right. So display lower, then you can input the guess. Rather than that, you just go back to this particular process, right? So after this box, this circle, we need to put that input guess, right? Also, inconsistent flow direction is hard to follow. So suppose start is here, stop is here. So we generally want start at the top, is at the bottom, right? And we need to finish that. Okay, so these are the things we discussed, that how many rows, one and one, zero, process one input, one output, one. Since in case one and one, these option, this connector will help basically, because connector has multiple options. So when you end up with multiple inputs, please use a connector to manage that, because you cannot violate these rules. Anyone have any question? You can be commenting. So this is also another thing. You see, you cannot have multiple input, right? For the process, you cannot have multiple input. So how to solve it? You have to use a connector. So just use a connector. So this is a really good example. So there's a situation. So when you write the flowchart at the beginning, you will end up coming here. So suppose you write your first flow here like this, and then you know that multiple input you cannot allow into a process. So just use a connector. So modify that, because it is highly unlikely that you can use the connector at the beginning, right? You never know what can happen in the process, because you're processing your mind to draw the initial steps like that, right? Okay. So these are the complicated situations that can also happen on different conditions. All these can be very complicated. This is another important one quickly, that multiple user can actually interact with each other. Suppose a user is selecting the form, it correctly manually put something, and then the pre-fill form. Nowadays, most of the contact forms are pre-filled, right? So how the pre-fill actually works, because the system is working and they're interacting to each other. So flowchart can be like that. Please feel free to go through that. I'm not spending time on that. Now, BPMN is a modeling language in which they actually give the ideas that how you can draw complicated flowcharts. But this is actually not, we are following that, especially we're following the flowchart only, but feel free to look at that. Now, in the assignment, if I'm not sure what the unique coordinator will be, including, if it includes about BPMN, we didn't discuss about a lot. I just only found only one slide. That's why I just showed it here. I think that's it. So one of the main takeaway from today's lecture is the flowchart. And if we can follow all the steps, that, and the last thing is that we need to follow the exact notation from our PowerPoint or the lecture material. Don't use any other kind of symbol, different symbol. If you find in another textbook, don't follow that. So the connector have to be round. Yes, correct. It must be circle, right? The connector. Any other question? All good, right? So again, this week there is no lab. So from next week, the lab will be there from 7:30. Please feel free to go through the video again, because I talked about many tools. Please install the tool. At least install. Don't need to install. You just need a Gmail to log into the Google Colab, in which you can practice the Python coding, right? So everyone happy coding. So good luck everyone on the coding journey. Okay, if there's no other question, I can conclude the class, right? Okay, see you next class. Okay, thank you all.